Hello everyone, this is Cosmodius, and I'm going to be doing a video today on Stationeers. So this video is going to be pretty short and sweet, but not too short and sweet. I mean, it's going to be shorter than a regular video would be, and I'd probably be making another video right after just to show some other things off, but ultimately this video is to show off two things I've been doing, and to explain to new players the difficulty that this game actually gives you, and the large amount of garbage you have to go through to actually progress. So to begin with, we got my world here, which is called Test. And essentially, I've done a lot on this world already. It's not actually a lot, to be honest. I really haven't done a lot. I've actually just done the basics. I haven't even done the basics, really. I don't even know what I'm talking about. All right, so to begin with, we do have a couple of things to talk about. The first thing, I'm going to go ahead and cycle this so we can go outside. So I'm using, or I was using, I guess I'm not anymore. All right, never mind. All right, so anyway, the first thing I did was I set up my power, and I rushed the battery, and I set up my auto lathe. And whenever I had my electronic printer, that's whenever you get to make the battery, I set up the transformer, and I set it up to the solid fuel generator. The only thing is I wanted to automate the solid fuel generator, but I wanted to do it with a deep drill. And to do that, I have to set up a deep drill, I have to set up some centrifuges, and I have to consider how much power that all costs. Because as it stands right now, a sorter it's not going to tell me, is it? 5 watts, nice. Base power usage, 5 watts, okay. So a sorter basically doesn't cost a thing, but a centrifuge. All right, a centrifuge is 100 watts. So in total, it would cost me 800 watts a second to run up my system. So that way I could automate the solid fuel generator. And of course, that wouldn't be too bad, considering that once it backs up, I'll have quite a few things, except there's only one problem. So let's do some math here. All right, so 20,000 watts. All right, we're talking about 20,000 watts per second for each coal that goes in here. All right, so each coal that goes in here is 20,000 watts a second for 10 seconds. That is 200,000 watts. So we'll have 200,000 watts of energy. All right, and that would keep us, because keep in mind, we're far away from the sun. Wow, is this really not loading in yet? Oh, I don't care too much about it. If I get closer, I wonder if it will. Yes, it does. Okay. Developers' funny updates aside, so the sun's setting. We can't depend on the sun for pretty much anything. We can't even really depend on the sun because with freaking radiators, because we're so far away that we'd sooner get light from another sun than our own, from a radiator that could track the sun, really, if this was realistic. So here you have a solid fuel generator. We need a deep drill, and a deep drill would drill a hole into the ground, and we have to get one hydrocarbon sorted every single second. Or no, wait. So it takes 800 watts. All right. So I'm going to go ahead and do the math. That is 250 seconds of power we get. All right. For power to power our own power generation automated system. All right. So keep in mind it does shut off whenever it reaches its point, but 250 seconds is 4 minutes. So we have 4 minutes to actually get one hydrocarbon in order to basically get enough power to keep our system going, so that way we can basically indefinitely have power. As we do that, there is a problem. Every item that we put inside of the silo, or even inside here, we have to really consider how we're going to stack and what we're going to do to automate. So essentially, we would have a silo set up. And the thing is, we would want a stacker. But the stacker system isn't going to stack an item that essentially isn't a full stack already when another different item is behind it. It's not going to stack with that. So in order to actually build a stacker system, we'd have to set up 9 sorters, basically. And we're going to go ahead and quit this now that I've explained that. And let's go to, if I'm not dead and under the ground when it loads. Okay, I'm not. So here I've been playing around with some things. I set up a cryo tube, and when I open it, it blows out all the very, very cold negative 135 Celsius oxygen. But it doesn't get so cold that it actually bursts the pipe somehow. And I guess you have to really try to do that. So, yeah. Now we're going to come over here, and we have everything running. We actually need to stop running this, and we need our centrifuges to finish. So while they're finishing, I'm going to go ahead and show you some things. So here we have an IC chip that is turned off. I guess I turned it off. And here we have our code. I'm going to go ahead and go over the code. We have sorter 1 right here. All right. We have sorter 2 right here. Sorter 3. Sorters have 3 modes. Mode 0 is a splitter. So essentially, you'll send half of everything down one way, half down the other. Mode 2 is, or mode 1, my bad, that's mode 0. Mode 1 is a system that uses a special chip. So essentially, you program with this chip right here that I'm about to show y'all. Got no settings, you set the devices, here we go. It has these whitelists. And the idea behind the whitelist is you would set these whitelists to what you want them to sort. And essentially, that's mode 1. These sorters will not use anything unless you mode 1 or 2 it. Wait, what's going on here? Uh-oh. Whoops. Oxygen tank. Come on. Nice. All right, problem solved. So essentially, even though we program them here, if the sorter is not set to mode 1, it's not going to use it. And if I set this sorter to sort belts, and then we take this out, turn it off, put it back in, turn it on, it's still set to belts. But the motherboard here isn't what saved that information. It's actually saved inside the sorter itself. So if I do this, spawn another one, do that, I guess I was wrong. I guess it is saved on that chip. Whoops. And you'd also probably have to keep the computer right here too, if that was the case. And it'd have to have this specific chip in it. Very nice to note. So mode 2 allows you to use logic to control it. So that means that the sorter on mode 1 and 2 is not going to do anything until you set it up. So it will reject everything until you start adding things to it. So what side rejects and what side doesn't? All right, so the side that is accepted is the side right here. This is the accepted side. The side that's rejected is the side right here. This is the rejected side. It's the same side as the input, which I find very annoying because the developer kind of did that for a lot of things. Like, for example, and by developer, I mean that plurally. I apologize. So the filter filters forward instead of to the side. So anything filtered isn't filtered out. It's filtered in, basically. But it's considered the output, while this is the unfiltered. So the developer is certainly not from where I'm from. That I can tell you. All right, so I think we're pretty much done here with these. Yeah, we are. Okay. And we've already dispatched all of this. No, we haven't. We got to dispatch all of this, get rid of it all. They do not stack in here at all. They don't stack at all. So they're all coming out, and they keep coming, and they just keep coming. And let's not forget that the computer also contributes to the electricity. So in reality, you probably have 4 minutes. Every 4 minutes, you have to get a single hydrocarbon. So let's go ahead and pump out our hydrocarbons right now. We have 28. We don't know what time that was for us to get that. And here we got a bunch of junk. What? No, that's not what I wanted. I'm going to end up deleting myself. All right, we'll delete all this first. And then we'll start the experiment. No, I don't need you guys here. This is from earlier. The rest went down there. I know. Iron frame. Stairs. Oh, seriously? Okay. Well, at least it didn't destroy our suit completely. Now we gotta duct tape ourselves. Somehow duct tape prevents air from escaping. I guess that's what its purpose was supposed to be, isn't it? Oh well. That's our fault. We made the latter mistake with stairs. So for future reference, don't add it like that. Even in the regular game, I wouldn't add it like that anymore. So we'll go ahead and undo these now. And now we have to see how long it takes to get hydrocarbons. So we're going to keep those running. And we're going to start this up. So to go through this real quick, let me pause it. Okay, so I paused it now. We're about to set a clock. And stopwatch online. Timer 4 minutes. Start. All right, so we started it. It's going. Let's go ahead and go over this. So these are the sorters, sorter 1 through 3, and then here's the code for carbon, or here's the code for hydrocarbon. The actual coal comes out, not hydrocarbon itself. Very important to note if you're going to try to make some solid fuel. And then here's the aliases for the R1 and R2. So this just stores the carbon ID in here, the hard carbon hash. And this one stores the hash that's inside the sorter. So we just type sorter hash to remember. No big deal. So it sets everything to mode 2 after yielding. Then it loads, or it loads the information from the logic memory to R1. So now we have the memory hash stored. Checks to see if sorter is occupied, right? So it loads the occupant hash to get the hash of if it's occupied or not. And if it is, let me go ahead and make sure all of our, yep, everything's good. Okay, go back down to the floor. If it is occupied, then it goes to, if it's occupied by coal specifically, then it goes to this function is coal. If it's occupied by, if it's not occupied by coal, it rejects it. All right, so accepts, rejects. but we can actually dictate what side it comes out of. So we can make it to where it rejects coal and accepts everything else. So that way the coal will go where we want it to if we wanted it to go there. We could literally alter, all we have to do is 1, 0, 1, 0, 1, 0. And we're not really going to do that, so we're not going to export that, because that's just really, we want the side that is being accepted here on purpose, because as you can see, it's faster to make things flow out here like that. So the side that is accepted is the is it coal, right? It's 0. So 0 is right here. 1 is right here. Remember that. This is the developer making this game. All right, so I don't know if that's how it works in wherever they're from. And we're on the last minute now. And we have, let's see, 1 hydrocarbon. And it's still processing dirt. So far we're still processing dirt. We're on the last minute. And our RPMs are max. Nothing came here yet. So that's kind of weird, because it's supposed to come here before it comes here. I know, because I set it up that way. So that makes me wonder if this is actually clogged. I'll need to build a chute really quick if that's the case. And then after that, we can stop the timer. That's not clogged. All right, so if it's not clogged, we got 2 hydrocarbons now. All right, and then we stop it now. So now we'll go ahead and let these do their thing, even though this is a little bit extra credit here. But, usable hydrocarbons, we got 2. For every dirt we get, we have to get that dirt processed out quickly. So essentially, every dirty ore that comes from here, in reality, you should split it into 1 thing each. Or if you're doing 2, you should split it into 5 for 2 centrifuges. So 5 here, 5 there, and that would be more efficient. So then when we come over here, as you can see, we don't have stackers here. And we would need those stackers to maximize our efficiency, but the thing is, the problem, okay, so for the stackers for the coal side, we would probably want stackers for 15 stacks of coal, or stacks of 15 coal is what I meant to say. And the reason why is because the battery takes in 3.6 megawatts total to be fully charged. If we were to divide that up, right? So essentially each coal generates 200,000 watts total, and it takes some time to do that. And essentially, it takes 10 seconds, and that uses 1 coal, so it's 20,000 a second. So after that moment, after that time, we end up getting a certain amount of coal total that would be, we would obviously want to cut it off when we get a certain amount of coal that's not too much. So we probably wouldn't use a silo. We'd probably just decide at a certain point we're going to stop all these machines. We're just going to say, all right, enough, right? It's all backed up. To design that, I just want y'all to know that would be a heavy undertaking. That is not actually something that you design in your sleep and you dream of it, the answer to it or the solution to it. No, there's a lot of steps there. So essentially, the stacker for this side wouldn't work either. Or the stacker on the coal side would work. The stacker on the non-coal side wouldn't work. The reason it wouldn't work is because of the fact that, actually, let's go ahead and look at something here. How much does solid fuel generate a second? I wonder, I've never tested that. I've never tested to see. I don't think it actually does generate too much a second. And I say that because I don't know. I might be wrong, but I don't know. So anyway, to stack anything here, we would have to stack each individual ore. So in total, we only got 2 hydrocarbons the whole time. Okay. So each individual ore, like you see, there's 2 cobalt here and 1 there. We would want that to stack into 50 before anything. But if we were going to do that, we would need sorters. All right, so we would need more sorters for that. We would need literally a sorter for every single ore in the game. And that's just, and there's no ice in here coming in. So the deep miner cannot help you with ice. But the auto miner can. So if you were using the auto miner, you'd be able to do that. The auto miner, by the way, the regular auto miner, I think there's only one. It says 200 watts, so it used 200 watts a second. I don't know how much coal that would give you, because I don't know the density of everything, but I know it would certainly load you up with a lot. So now that we've done this, let's go ahead and test our sorter out, see if it works after I finish explaining this. I think I did finish explaining it, then it jumps back to main. Yeah, it goes back to main, all of it, and then after that, after they JRAW, which means they jump back to the thing that came after the AL command of the branch request. If you don't know MIPS, then I apologize. But then, this chip here, it does its thing. Reset it, make sure it's working. Let's go ahead and do our deed here. So there is still a way to stack them, but stacking them will require perpetually throwing these silos out, outputting from these silos, and doing something to them, right? So we would at least need one sorter to stack them eventually if we were going to do that, and that would be so inefficient, and we'd just be better off manually doing it whenever the time came. But there's another way to do it, and that is instead of stacking them, we could also we could consider waiting until the centrifuges are full and then doing that. But if we do that, we have to upgrade our battery immediately, so that way we could do that. All right, so now we've done the deed. There are 12 items in here. There are 2 items in here. All right, so our hydrocarbon was successfully sorted. It's successfully sorted out with that code right there and this memory chip. That's exactly the kind of stuff I'm talking about that you have to know in order to play this game. It's kind of silly, I know, but also here we have the cryotube. I have no idea how to use the cryotube other than either cold nitrous oxide, which isn't necessarily the best thing to freeze yourself with, or cold oxygen. And apparently cold nitrous oxide can actually bring your body back to life, but it can also kill you, so I'm not sure how that works. Cold oxygen can heal you in the game, but only if you're in that cryotube. If you're not in the cryotube, it actually kills you instead. So yeah, there's that. And it's supposed to stop your vital function, so before I get off, I'm going to go ahead and test it out. I think we're going to have to do it this way. It's going to get really cold in this room, so I just want to make sure that I maximize my life expectancy here. That's all I'm trying to do. All right, there we go. It's negative 2 degrees. We don't have a stand Well, that's a standard shoot. Yeah, we don't have that. Let's go ahead, though, and take all of our stuff off. Is this on? Yeah, it's on. Sweet. Now we're testing it out. Because we're basically frozen. All right, so we're going unconscious, we're going unconscious. This is pure oxygen, so there's zero reason why. All right, and supposedly we're healing somehow. Because as far as I'm concerned, all of my body limb parts are yellow at this moment, so that might just be because we're frozen. Our vitals aren't going down, and at any time we can just undo it. So we undo it, put our suit on, our helmet, and our backpack, our shoes, our belt, and we somewhat, I don't know. I just don't, oh my goodness, no. All right, anyway, so thank y'all for watching, and that's going to be it. So, peace.